Good evening and welcome to mathsatoka online class. In today's video, we'll be talking about organic chemistry, arcade group. Okay, please, this is the second video. You can watch the first one. And if today is the first day of watching our video, please consider subscribing. Okay, now, an arcade group is defined as a group formed from the arcane. They are formed from the arcane by the loss of just one hydrogen atom. Okay, and the general formula is given by, you know, that an arcane for arcanes for alkanes we have CnH2n plus 2. Okay, then alkyl are formed from here. Alkyl Alkanes are formed from here by just removing one hydrogen. So it's now CnH2n plus 1. Okay, and then we denote them as R. Anytime you don't want to write this formula, or you know that you are talking about an alkyl, you can just represent them with what? With R. Okay, so let us write at least the five. Let's write alkyl group for just 5 members of the alkane. Okay, 5 members of the alkane. Well, we have this. This is the parent name. The parent name, the alkyl group, and then the formula. Okay. Now for the first one is methane. Okay. Now it from methyl. Remember that this is alkyl, so it will be methyl group. Okay, methyl anyway, not group. And it's what? CH3. How did we get CH3? That is from CnH 2n plus 1. Then if n is 1, we have that what? C1 H 2 times 1, 2 plus 1, 3. That is CH3. Okay. Then the next one is ethane. Ethane, then you have to call it what? Ethyl. And remember that this is a homologous series. It's a homologous series family. So we can just get the next member by saying adding one H here, one C, and then two H. You know that in a homologous series, we get the next person by just saying by adding just CH2. Okay. So if we add CH2 here, we'll get the next person. Or we still use our formula by saying C2H 2 times 2 4 plus 1 5 H5. The same thing. If you still want to use this one by adding this, you have what? C2H5. The same thing. Okay. Then the next one is what? Propane. Propane. And it is called propyl. This is the parent name. This is where they are gotten from. So this is propyl. Okay. Propyl. Sorry, ethyl. Propyl, and then it's simply by adding CH2 to the next person here, or you can use the formula N is now 3. So we have what? C3H7. Okay. The next one, number 4, is a butane. 4 is butane. Butane, and it is called butane. Butyl. Okay. Butyl, and then it is called C4H. Add to here 9. Then the next one, and the last one, because say we want to get 5, 1, 2, 3, 4, 5, is pentane, and it is called pentyl. Okay, that is C5H11. So that is that. So you should know that just alkane group are gotten from the what? Alkane. They are gotten from the alkane by removing just one hydrogen. Okay, and that is that. So now let's go to the next one. And the next one we are moving is now the functional group. The functional group. Okay. Now, a functional group is defined as an atom or a radical or a bond common to a homologous series, okay, which determines the main chemical property of the series. The functional group is what determines the what? The main chemical property of the group. Okay. Now some we're going to draw some families of the homologous series, indicating both their general formula, their functional group, their prefix, and their suffix. Okay, so we're going to start from their name so that you will know all the homologous series, all the families of the homologous series. So I have their name, the general formula. Okay, we now have their functional group. Then we now have their prefix, and we now have their suffix. Okay, so now the first one we're going to talk about is the Alkane. Alkane is the first one, the Alkane group. Now the general formula for the Alkane group is what? CnH2n plus 2. Don't forget. And their family, their functional group is just one bond. The Alkane is just one bond. That is their functional group. Okay, it's just one bond, and they don't have a prefix. They just have the end, the suffix, because they are always used as the parent name. So they have the suffix, and they are called the ane, ane, like the way we say butane, okay, pentane, or you can say butuane, butuane, sorry, or pent1n, or prop3n, that kind of thing. So they end with ane, ane, and is what is called the suffix. Okay, they cannot be used as prefix. Yes, they are always used as suffix. So the next one we'll look at is the Alkyne group, or Alkene. Let's look at Alkene group. For Alkene group, don't forget that Alkene group is gotten from Alkane group by removing two hydrogen. That is CnH2n. If you remove 2 now, it's just CnH2n. Okay, and their functional group is double bond. They are double bonded. So this is 2 remaining 1 2 to make it 4. I hope you have to complete this 1 2 3 4, because carbon always take 4 chain. So 1 2 3 4 complete. So this is 1 2 3 4 complete for this one. 1 2, I can just say 3 4 complete for this one. Okay, anyway you like, you put the hydrogen. I hope you know that all these things I'm putting is either hydrogen or the halogen, or halogenous group, anyone. Now you need to know that what the alkane and the alkane, they don't we don't use them as prefix. They only have the suffix. Okay, even the three of them self, they are all used as, in fact they are all parent name. The alkane and the alkyne, they are all parent name. Alkyne. Please know the difference between alkyne and alkyl. They are not the same. Okay, alkyne is gotten from alkane, alkene, by removing another two hydrogen, but alkyl is gotten from alkane by removing one hydrogen. So the general formula for this one is CnH2n plus 1, but this one is CnH2n minus 2. Okay, so please know the difference between alkyl and alkyne. They are not the same thing. So for alkyne is CnH2n. We are removing extra 2 from here. That is minus 2. Okay, and it's triple bond. This one is triple bond, C and C. So to complete it 4 and complete it 4. So the three of them are not used as prefix. So don't forget that this one is in, ene. Yeah, like propane, pentane, butane, or non-1-ane, non-10-ane, something like that. And then the last one we know them as yne, yne. So that is that. We don't use them as prefix. So the next one we're going to talk about is the AKANO. Alkanol. Alkanol. That is the OH group. For the Alkanones, now apart from these three, now the rest we are going to look at always use the alkyl group. They use the alkyl family then attaching maybe an OH or any other group to it. So anytime you are writing any one that is not these three, what you must use is the alkyl. You must use the alkyl. So we are going to say that it is what? CnH2n plus 1. We are using the alkyl before we add the OH group. That is all. The null there means OH group. Okay. So AKANO is what? The alkyl with the OH group. Okay. So you know, sometimes if you don't want to write it like this, you can easily write it as this one is R. You can write it as R. You now put your dash and put your OH, and R represents what? The alkyne. Sorry. So we always use alkyne. Sorry. Alkyl. I'm the one making mistake. Alkyl. Okay. So this is the alkyl plus the OH group. So and their functional group is the OH. The OH is their functional group. Okay. And then they are not used here. They are not used here. They are used as the suffix as well as a parent name. So it is null, N-O-L, null, like pentanol, hexanol. Okay, all, O-L. Okay, pentanol, hexanol, and the rest of them. So the next one is the halogen alkane. The halogen alkane. Halogeno Alkane. Halogeno Alkane. Now, for the halogeno alkane, don't forget the halogens. The halogens are the what? The iodine, the bromine, the what is the chlorine. So it's simply what? Don't forget that apart from these three, what we use is the alkyl. So you just write your alkyl, CnH2n plus 1, my alkyl. Before I will now add my halogen. My halogen will present them with X. Okay, will present them with X, where X is my halogen, and then their functional group depends on the halogens. So it depends on the halogen, and all the halogen we have the chlorine, the bromine, the iodine. Okay, and they are not used as the parent name, so we use them as the prefix, and where you can just say 3-halo or 5,2-bromo, 3,5-iodo, that kind of thing. So we have for the X, we call them for the halogens, or let me write it the way you understand it. Just know that the halogens comprises of what? The chlorine, the bromine, okay, and the iodine. So we use them as what? Bromo. Okay, let me start from chlorine. Chloro, okay, bromo, then iodo. Okay, so that is that. The next one is the amino alkanes. Amino alkanes. Now, for the amino alkanes, don't forget I told you that is only these three are different. The rest is from the alkyl. So first of all, I'll write my alkyl R, or I will represent it with this. Then write my amino. The amino is what? NH2. The amino is what? NH2. So their functional group is that NH2 is their parent group, and then we can use them as the prefix or as the suffix. They can always form the parent name as well. In the parent name we call it amine, but in the prefix we use them as amino. So this is amino, but in the prefix, in the suffix, call it them amine. Okay, amine. So the next one, these are all the homologous series. The next one we'll talk about is Alkanal. Okay, let's talk about the Alkanone. Now for the Alkanones, uh, don't forget that first of all we have the you have the R. I thought that we always use the alkyl. So you have the R and then have the CO group, then you have the R closing it. So anytime you have RCOR, that is this CO this again, then they are called the Alkanones, and the parent name, the functional group is C double bond O. C double bond O. Okay, then you now have this and this attached to it. Okay, so C double bond O, and they are used as what? Parent name as own. ONE, own, not one but own. Okay, so the next one, permit me to clean this one. Let me start writing from here because my board is too big. So I've talked about the Alkanone. Let's talk about the Alkanal. Alkanal. For the Alkanals, don't forget that we always use the alkyl. So we use RCHO. As simple as that. RCHO. So we are using CHO. So it's going to be C double bond. Okay. Double bond, or let me just say C double bond O, then one bond H. Okay, C double bond O, then one bond H, then any other thing can be here to complete it, and then we use them as a prefix as Al, R. Okay, that is Alkanal. We use them as Al. So the next one is alkanoic acid. Alkanoic acid. Now, for alkanoic acid are like Alkanone. Okay, they are like Alkanone. The only difference is that it is double O. So for the alkanoic acid is R C double O and another R. Okay, R C double O and another R. So how do we do that? Is that alkanoic acid? No, 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 no. They are gotten from the Alkanal. They are gotten from the Alkanal, and it is R C H, okay, COOH, sorry, COOH. Okay, so RCOOH, alkanoic acid. They are gotten from, okay, oh, we can even get it from the alkanol. From the alkanol is R, okay, but there is no C here. This is ROH, but the alkanoic acid is RCOOH. So how do we represent them? R, okay, so sorry, their functional group is C O and OH. That is O and another H. Or you write it together, OH. So they are used as oic, pentanoic, hexanoic, something like that. Okay. Heptanoic acid, and so on and so forth. So you need to calm down and master all these homologous series, their functional group, and their general formula. It will really help you in naming any compound when we are going to enter IUPAC nomenclature. It will really help you very well. So the next one is alkanoate or ester. Alkanoate, alkanoate, or you call them ester. Now, for alkanoate, alkanoate is that RCOOR. Yes, RCOOR. So we represent them with what? Their functional group is COO. So this is their functional group, C double bond O, then one bond this side O. Or we write it like this. Let me write it very well. C double bond O, one bond O. Then we now have one here. So that is COO. So the next one will now have they are called OAT. Yes, OAT. That is pentanoate, hexanoate, and so on and so forth. They are called the OAT. So the next one, the Cyano Alkane. Cyano, okay. The Cyano Alkane. Now, for the Cyano Alkane, we have Cn attached to it. That is R with your Cn. Don't forget what R is. R is still your alkyl. Okay, so R, Cn, and they are Cn. That is C, triple bond N. Okay, and they are used as the prefix as cyno, the same name, cyno. Okay, we keep moving. So the next one is the Alkoxyl Alkane. Alkoxyl Alkane. Alkoxyl Alkane. Now for Alkoxyl Alkane is simply ROR. Very simple. ROR, and they equally called the ether. This one is called the ester, but this one they are called ether. Okay, ROR, and then we get them by just that O. That is their functional group, and they are used as alkoxyl. Alkoxyl. Okay. Then finally we now have the alkyl amine. The alkyl amine, that is RCO, then amine NH2. RCO, alkyl amine, RCO, then NH2. So we get them by C, double bond here, O, then one bond, the amine NH2. So we use them as amide. Okay, so that is that for the functional groups. Let me check my time. Okay, so you will take your time and then study it very well. Take your time and study it very, very well. Just know that only the alkane, the alkyl, and the alkyne have different. For the alkane, alkane is simply CnH2n plus 2. Then remove 2 to get the what? Alkene. That is CnH2n. Then remove 2 again to get the what? Alkyne. That is CnH2n minus 2. These three are different. But for any other one, we use the alkyl plus any other functional group. Okay? That is the alkyl. And the alkyl is what? Just removing one from the main person. That is CnH2n minus 1. Okay? Sorry, plus 1. If you remove 1 here, it will not be plus 1. So that is that. So you take your time to study that very, very well. Okay? So we can go through them again. Let's go through them again. The next one we talked about is the Alkanol. And Alkanol is the OH group. Alkanol. And don't forget that we are using this man. So it's simply ROH. Very simple. And their functional group is what? OH. And they are used as what? As prefix. That is pentanol. So they are called the all. We are just going through them again. The next one is we talked about the halogeno alkane. Halogeno alkane. Halogeno alkane. Now all you need is the halogen. Just R with your halogen. We represent the halogen as X. So the halogen can be either chlorine, bromine, or iodine. Okay, and don't forget that they are used as the prefix and not the suffix, as iodo, bromo, and chloro. Okay, so that is that. So the next one we talked about is we talked about the amino alkane. Amino alkane. Just put your R, then put your amino, that is NH2. As simple as that. And their functional group is the same, NH2. Okay, this is their general formula, and then their functional group is NH2, and they are used as what? As they are used as prefix as amino, but as suffix as amine. Okay, it's different from the alkyl amide though. It's different from the alkyl amide. For the alkyl amide, it is simply RCO before you now put the difference is CO before you now put your amino. So, and it is given by C double bond for the O and single bond for the NH2. Okay, so it's CO NH2 is their functional group. So, and so on and so forth. And don't forget the cyano alkane. Okay, the cyanoalkane are just your Cn, just the R with your Cn, very simple. Okay, that is C triple bond then N. That's all. That's all. So the next one is the ether and the ester. Know the difference between the ether and the ester. The ether are called the Alkanoate, while the ester are called the Alkanoate, while the ether are called the Alkoxyl Alkane. Alkoxyl Alkane. So the ether are called the what? The Alkoxyl Alkane, and it's simply ROR. That is for the ether. That's Alkoxyl Alkane. ROR, and it's simply the O. Their this thing is O. Their functional group is O. So, but for the ester are the Alkanoate, and the Alkanoate is what? RCOOR. Alkanoate, yes, RCOOR. So we put the C, you know that to complete it, this one will be double bond, while the other one will be single bond, so that this one will be complete. Okay. So don't forget that oxygen take double bond. These are the small things, and hydrogen take one bond, carbon takes four. So that is that, and so on and so forth. So thank you very much for watching. We are going to stop here. In our next video, we will now go into formulas. That is the empirical formula, the molecular formula, and the rest of it. So thank you very much. Please share to anyone that needs it. Don't forget to subscribe, like, and comment. Bye bye.